So now we come to the interesting part in this design to simulate torque and speed and position for the inner and the outer gear, and also plot magnetic field density maps. In order to do that, I will go here to result and right click on it and create transient report, select rectangular plot, and for the torque here I will plot moving torque, moving one torque and moving two torque here. And in this time, in this report, I will plot this torque with time and click here new report. And we can also go again to results and create transient report, create rectangular plot, but this time choose here instead of time the position. So I will in this report I will draw the moving one position with only the moving one torque like this here. And in the next report I will do the same, but for the moving two band as shown here. Also I will calculate in create transient report. I'll select data table and select here mean value and click OK for moving torque number 1 and the moving torque number 2 and click create new report. Also we need to plot the position in a single report for both inner and outer gear, and we need also to plot the velocity for both gears. And for the field map I will draw here a circle exactly at the center of this gear like this, and I will select it here and go to fields and plot magnetic field density map here. Check here specify name and specify folder and click here OK, and make this circle white in color and full transparent like this. Now let's validate that everything is okay with our design. Here we have like intersection between cylinder number 8 and these parts. Let's check this. This is cylinder number 8. Often this happens because of segments definition here. So we will add here 100 segments for this cylinder for the inner and the outer diameter. And let's check again. We have here like touching bands. So let's check the bands for the motion. We can go here to view and select the top from here, and in this case we have like a touching band here. So for this band I will divide the radius here or the air gap by 3 like this, and now we don't have any touching bands. We can select this band also and and for the inner diameter for it, I will also make this air gap divided by 3 as shown here, so we don't have any intersection between the bands. Now let's validate again our solution. No problem with 3D model, no any errors about with the model. So in the first step, I will simulate the inner gear rotating with velocity of 500 RPM, while the outer gear is stationary with angular velocity of 0. Why we do this? We do this to estimate the point at which maximum torque happens, and at this point I will take the position and put it here as initial position, and then run both gears with their expected RPMs. So let's do this first. Here let's go to analyze all. I will pause this video now and continue it after finishing the solution. So during running I found this error here. This is because we forgot to divide the band here height with or sorry, multiply this with 1.1, and also here for the inner cylinder with 1.1 like this. Now I will run again the model and see you after finishing. So now the simulation is finished. We can check the torque for the inner gear. Here's a small torque. Moving one torque here is for inner gear, and the green one is for the large gear here. So to specify the location at which maximum torque happens, we can go to the plot here for the inner gear, the torque for the inner gear, and locate the point or the position at which maximum torque happens. So we can zoom this point here, and we can find that the maximum torque, maximum positive torque happens at 115 degree, about 115 degree. So in the position here, I will put 115 degree. Note that, this is this should be for the inner gear, and for the outer gear here, the position will be 0. Note that the torque that the outer gear is not moving here, so moving position is 0, and torque also for the outer gear changes between positive maximum and the negative maximum value. So now I will put here for the velocity for the outer gear about 100 RPM, and again rerun the simulation. The expected torque here is a constant torque for inner and for outer gears. So let's pause now the simulation, the video, and rerun the simulation. So now the simulation is about to finish. We can look at the torque for inner gear, which is the red one here, the small one, and the torque for the outer gear, which is the green one here. We can see that from this internal magnetic gearbox, we can transmit the torque and reduce the torque from about here. Let's make this in Newton meter. Sorry, let's make this in Newton meter here. From about 0.9191 Newton meter to 0.17 Newton meter. We can use the calculator to calculate the gear ratio. We can divide 0.911 by 0.17 to obtain the gear ratio, which is here about 5.35 approximately. So this is the torque for both gears. We can take this from edit, copy here, and paste it here to the result section. And also take the torque mean value here, and right here, or observe here that the gear ratio is about 5.3. Also, we can I will pause the simulation now. We can also plot the magnetic field density at any moment. Like here, go to view and select set solution context, and select any time here from the simulation, and click OK. Sorry, I will hide all this for now, and only I will delete this and select this circle for plotting the magnetic field density. And plot it like this. We can also animate this by right click here and go to animate and select all time for simulation here and click OK. And then click on animate here to animate this internal gearbox to see how field interact between inner gear and outer gear. It takes here only seconds to run. And the plot here is in 2 dimension. We can also plot the magnetic field density in for all parts in 3 dimension, but this will take more time. Okay, here the interaction between fields is like this. We can also reduce the mesh size in order to get more resolution or perfect resolution shape for the magnetic field density, but this will consume more time in simulation. So let's close this now and go to view all parts here, and I will uncheck plot visibility here and select only all parts here. Go to selection mode and objects and select all parts here like this, and go to extend selection and all object faces, and then right click and go to fields and choose magnetic field vector B, magnetic field density B, and then click OK like this. So this is 3D shape for flux density. We can hide all parts here and only leave the magnetic field density map like this. As shown here, it's very beautiful. We can spot locations for high magnetic field density between magnets here. So it's recommended to increase the back iron size here in order to avoid these saturated points. We can also run or animate the model here. Like we did in previous case. So it will take only several minutes. I will pause this now and resume the video. So now this is the animation for the internal magnetic gearbox magnetic field density. As I said, we can improve this magnetic field density map by increasing the back iron size for internal and or for inner and outer gear to avoid these dark red spots here. I hope that you like this video, and see you in next videos.